Developer. This morning we'll look at the past exam paper, February 2014, question 1. The question has two parts, part A and part B. Part A refers to figure 1.1 and it reads this way. Part A, section 1 wants to determine the peak-to-peak and RMS values of the voltage waveform V time t, and part 2 wants us to calculate the frequency and the period of this waveform. Part 3 wants us to express the voltage, input voltage Vt, and the current It as phasor, and we need to sketch the phasor diagram. Part 4 wants us to determine the impedance of the circuit. The whole circuit is shown here. It wants us to determine the impedance. Part 5 wants us to determine the values of the circuit components in this AC circuit, which provides or gives us the impedance that we calculate in part 4. And we are required to draw the circuit diagram showing the circuit components. Part 6 determine the power factor, right? Because the AC input voltage and the AC incoming current obviously have a phase difference, so there is a power factor. And of this power here, how much is the real power, how much is the reactive power? And finally, we are tasked to sketch the power triangle. So that's part A. Part B is a question from our lab whereby two parts of the circuits, the input supply voltage is monitored using channel 1 of the oscilloscope, and channel 2 is used to connect across a 2 ohms resistor, and the current waveform expression is given. So we are tasked to draw one full cycle of the waveform displayed by channel 1 and channel 2 when the vertical scale setting of the oscilloscope is 5 volt per division and the horizontal scale setting is 1 millisecond per division. So this is something you've done in your lab, right? Now, to answer this question, we need to revisit the typical sinusoidal waveform expression. Right? Normally we write a sinusoidal waveform expression as Vt is equals to the peak value sine of A plus a phase shift. Right? So if I have to compare the given voltage waveform expression and the current waveform expression, part 1, I can derive a few things from here. For example, I know that the peak voltage V peak is 20 volt. Therefore, the peak current is 5 ampere. What else do I know? I know that omega, which is the angular velocity that we use, which is equals to 2 pi, the frequency is actually 628 radian per second. Alright? The phase angle or phase shift, we call it, for the voltage is V is minus 36 degrees. And the phase shift for the current I is actually a positive 30 degrees. So very quickly, from just the sinusoidal waveform expression, comparing against what's given to me, I can get all these values. Now part 1 wants me to calculate the peak-to-peak voltage value. That means V peak to peak is actually double, right? 2 times V peak, which is 2 times 40. That's, I'm sorry, 2 times 20. That's 40. Okay, that's the first answer we want there. Then what we are required to do is to calculate the RMS value. Now we recall the RMS value is actually the peak value divided by square root for a sinusoidal waveform. So this gives me 20 divided by square root 2, which will gives me a value of about 14.4 volt. Now RMS value is commonly used when let's say we measure voltage based on our digital multimeter. Alright, so that's the answer for part 1. Now when we go on to part 2, part 2 wants us to calculate the frequency. Now if you notice from here, the angular velocity is actually 2 pi f. And from the waveform, I know it's 268 radian per second. Now if I calculate the frequency, it means 2628 divided by 2 pi, which gives me about 100 hertz approximately. So that's the frequency. Alright, and finally the period. Now period of the waveform or cycle, t is given by 1 second over the frequency. So it's 1 upon 100, which is equals to 0.01 second, or we call it 10 millisecond. Okay. Now remember, the period is actually for one cycle from here to here. That is what we mean by the period. Okay, so you have the answer for part 2. In part 3, we are asked to express the voltage and the current in their phasor form. Now phasor form, we write it in this way: V with a straight with the tilde on top is the V RMS value at the angle, the phase angle, right? In this case it's minus 36 volt, and RMS value which we have calculated here is 14.4. So it's 14.4 angle minus 36 volt. Sorry, 36 degree, right? So that's the answer for voltage. Similarly, for current is IRMS plus 30 degrees, which is equals to, for current we have 5 divided by root 2, the angle of 30 degrees ampere. So this is approximately 3.53, and it's 3.536 at the angle of 30 degrees ampere. So what's left now is for us to draw the phasor. Now the phasor diagram is something we draw which goes in a circle, right? So V in this case is 14.14, but it's negative 36, so it is the horizontal line. Negative 36 points downward, so this is 36 degrees, and that's my V. Okay, whereas current is a positive 30 degrees, so positive 30 degrees point upward, right? So this one is 30 degrees, where the I phasor is. Remember, the phasors goes anti-clockwise, so this is my phasor diagram. Alright,